I hope you guys had a good lunch. So my name is Andrey, and I'm going to talk about, this letter combination. Many people ask me how to pronounce that, and it's quite easy. It's Sshoogr. So salt, pepper, sugar. So my name is Andrey, and I'm primarily a Java developer, Groovy developer. And I always position myself as a developer because I like writing code. I'm still actively writing applications. But the thing is that in the last 2 years, I have been involved so much into helping organizations, my clients, to actually deliver, to build software delivery pipelines, to automate stuff from the beginning till the end, from development to production. That sometimes some people make only a DevOps guy, even though I don't really like this term. And I really like automation, so I try to apply it everywhere. And Groovy is perfect glue for any kind of automation, so you have to use it, especially if you're a Java developer and especially if you're a Groovy developer. I'm co-author of Groovy 2 Cookbook. I'm co-organizer of Latvian craftsmanship community. I'm from Riga myself, and the Devturning conference, also happening in Riga. You can find my connection details quite easily. You can tweet me, you can ask me questions later on if you have them. But that's not interesting. The interesting stuff is going to start later on. Before I jump into showing you what Sshoogr actually is, what it provides, I want to give a bit of background, how it was born, and what was the frustration that led us to creating a new DSL in Groovy. As probably many of you, Java developers, Groovy developers have been working on different size enterprise projects, maybe not so enterprise projects, and you had to invest into spending time into building your stuff with Maven or Gradle, and the teams that were composed, the teams that I've been in, mostly were composed of Java developers, and we had a dependency on operations guys, obviously, and we had a dependency on architects who were forcing the overblown architectures onto us, and we need to support all of that, but still at the same time delivering code, which was not always the best thing to do. And we also, of course, had many environments. Development, test, QA, well, most of you, I guess, guys have that as well. It's more or less industry standard. And the problem was that infrastructure changes were influenced by things that were not under our control. So architects were saying, now we're using this version of the product, or now we're using this application server, and suddenly we add a new layer to the system, which, of course, was not intended initially. And this was making configuration of the environments, configuration of deployments, and automation in general. This was making it very difficult. And given the tools that we're using at that point, mostly Ant and Maven, we also had issues with automating that stuff. Plus, another major issue in the industry, and maybe it's not that much at the moment because DevOps is moving forward, and more organizations trying to adopt principles of DevOps inside them. But back in the days, operations guys, and still there's a lot of organizations that follow that pattern. That operations guys is kind of an isolated kingdom, living somewhere on a different island, and you don't have access to them, or you have access to them, or they respond very slowly. They don't have time because they're busy supporting production. They don't have time to configure your development environment and configure your new Jenkins server or change the job. So you have to do it yourself. That was our situation. I think maybe most of you have seen this as well. Also, the development infrastructure that we had, all the Jenkins machines, all the Sonar version control, all that stuff, we had to support ourselves because operations guys were either too busy or the deliverables that we're doing was not good enough for us. We had to change them ourselves. And initially, when we had this mass of Java code, Groovy code, and application they want to deliver, we wanted to automate at least some of that through SSH connectivity. So trying to connect to the server and start deployment process, automate the configuration process, and maybe also make it repeatable. So of course, SSH protocol is probably one of the mostly used automation protocols at the moment. You connect to the remote server and you do what you want. The first blood that we had, the first thing that we started using, and because at that point we already switched to Gradle, and because Gradle has nice support for Ant built in, you can already start using SSH connectivity now already with Gradle, no problem. It's already built in because Ant has SSH exec task, and Ant has SCP task, which you can use to upload files and execute remote commands. The problem with Ant and the problem with the way it works, it's because for every task you had to specify all the details, plus every time you call this task, you actually make a new connection. Which, of course, it's fine if you do only one script execution, but of course, with time, our scripts were growing and they were doing more and more things. And having this repeatability, it definitely violates like the clean code principles. Plus, the deployment process became very slow because you had to connect many times. So we thought that, well, we're already using Groovy, we're already inside Gradle, so Gradle provides very nice DSL for build stuff, for building stuff, and we decided why not to create another DSL, which Groovy is perfect for. So Sshoogr was born that way. And Sshoogr is essentially SSH wrapper for a very nice DSL for working with remote command execution and remote file copying. And it fits very well, at least for our use cases, into deployment procedure because we can do whatever we want. Plus, reuse all the knowledge that we have. So, the main Sshoogr features are remote command execution, file uploading and downloading, and another important thing that was very handy to us is tunneling. So we can start, especially when I have like a firewall settings that block you from deploying directly to production or directly to some environment. You have to use tunneling in one way or another to get through that, to make a hole in the firewall. Oh, it doesn't work. Yeah, now it works. So at this point, Sshoogr is the version 0925, which was released 2 days ago. And well, it is a stable version, so don't be puzzled by this number 0. We're still going to version 1, which is probably going to happen this year, I hope. But it's already stable and it's already working. Now, before I jump into the syntax of syntax Sshoogr, I would like to show you what kind of use cases I use it for personally. Well, of course, the simplest one, I just execute any commands and any remote commands over remote server. So if I have something that I want to automate, I just make a simple Sshoogr script and I put it in version control and I automate that stuff on Jenkins or any other CI server, and this works pretty well. Another thing that I use it for quite often, because Sshoogr by itself is only a SSH wrapper. It provides nice DSL for working with the command execution and processing the results of those, but it may be not a fully blown provisioning tool. And of course, with the Sshoogr and with general bash scripts, you can implement sort of a provisioning initially, and that's what actually we did initially as well in our project. But you will soon realize that fully featured provisioning tool would do it a bit better than your custom scripts. And Sshoogr can be a good glue between provisioning tools and your automation scripts. So you can just have your Puppet code or Ansible code or Chef code somewhere in version control, and you can make Sshoogr package it and put it on the machine you want to provision. And that machine could be either virtual machine running in your local laptop, like a Vagrant machine, or it could be a remote machine running somewhere on the cloud. And you could use the same process of getting the provisioning code, uploading it to the node you want to provision, and then run that provisioning tool on that node to install stuff to do the next step of provisioning loop. This works very well in situations when your provisioning code develops together with your application code. So let's say you have a version, I don't know, 1.1 of your provisioning code of say a set of Puppet manifests that define the architecture of your application, what kind of components it needs, and you have your application code, which could be 1.2. And Sshoogr can, grab one version of provisioning code, grab a version of application, and combine them together and put them, provision the environment completely fully. Sorry. the thing is that some of those tools, like Puppet and Chef and Ansible, they provide additional orchestration on top of. They provide their own orchestration tools like Puppet Master and Chef Server, and those solutions usually work very well in operations-oriented companies. But if you are a development-oriented company, if you develop code of your application, plus you develop your infrastructure as code, plus you develop your database code, you want that to have the similar release cycle and release mechanism. And with the help of Sshoogr, we implement that in very organic manner, because we could take the code in the same way we take application code, and we can deploy it in the same way we deploy application code. And another thing I use Sshoogr for quite often is testing the state of the infrastructure. So it's kind of a mini monitoring tool, but it's like a monitoring tool, but it can be run as many times as you want, and we express it in a bit different way than simple monitoring. So we can just log into the SSH remotely, run our tests, get some reports back, and we can run all this process in CI server like Jenkins, for example, and publish the results so we can see how the different tests were passing. And I will show you the example of that in a while. Of course, tunneling, as I already mentioned. So if you have a machine you want to access that is located behind the firewall, or usually it happens with a jump server, so you can connect to a jump server, and then you have make a tunnel to a specific server and open the specific port, and then you have a connectivity inside your script to that port, which is very handy. Another use case that I found in some of my clients that had to use Sshoogr for is that development environment and production environment, they are completely isolated. So you can't really, the production environment doesn't even have access to the internet, doesn't have access to artifact repositories. Don't ask me why, but that was the case. So the idea was that we at least have some hole in the firewall, and we can use automatic scripts to actually grab stuff from development and put it to production without breaking any company rules. Another thing I'm using Sshoogr for is that I have a number of Raspberry Pi devices in my office, which I use mostly for voting system and for the events that I'm helping to organize. And those devices, they are largely they usually, when you start them up, they end up being on different networks. Like if I bring it to an event, it's going to be usually a different network. If I bring it to my office, it's going to be a different network. If I'm bringing it to my home, it's going to be a different network. So I'm using a bit of magic to discover the IP addresses of my Raspberry Pi devices, and then I pretty much use the same provisioning loop as I showed in the first use case, and to provision my devices, to update their configuration, to grab the logs, maybe the voting logs and some performance logs. And this works pretty well as well. Okay, let's jump into the Sshoogr syntax and show what it provides. First of all, to start using Sshoogr, you don't need to install anything. You can use plain Groovy setup, and you can use grep annotations to actually grab Sshoogr library and run it together with your script. And this is the simplest way to do that. So you just do one grep and do one import, and then you have the full access to the Sshoogr syntax. Then you can define different defaults, like what is the default user you use to connect to your remote machines, what is the default key file, for example, and different login options that you can specify as well. And the most of the work is happening inside the remote session method, which gives you access to a few abstractions and few methods that basically build up the DSL. So the most obvious one is the exec method, which allows you to execute remote command on the remote machine. But of course, it's not the only one. The more interesting one is actually the remote file abstraction. It allows you to construct a reference to a remote file and act on that as it is almost like local. So for example, here we can assign the contents to the file in the same way we would do it with local files in Groovy. Also, because Groovy has multi-line support, you can assign full content of the file to a remote file using multi-line syntax, multi-line strings. Also, remote file supports appendable and writable interfaces, so you can do this kind of chaining of contents of a file from local to remote and back. And this is expressed quite nicely, I think, with the help of Groovy left shift operators and chaining. Also, another feature that Sshoogr provides is copying of files. It provides a built-in set of closures to actually do a copying of files from remote machine to local machine and the other way around. And I hope it's quite obvious what's happening here. So we take the local directory and copy it, the whole contents of local directory, copying it to remote directory. And of course, we can switch the sites. It works that well. You can also make a list of files in this way, so you can specify how many files you want to move. There is another example of combining together execution and copying. So in the first case, we create a zip file on the remote machine, and then on the second statement, we actually copy the created file to the local machine. I hope it expresses very, very nicely in this way. Also, another pretty common use case that we had with the copying files is that sometimes you have to copy file to a location where the user that you're using for that doesn't have permissions to. But still that user have a sudo permission. The way to do it is that you copy it through a separate directory, and you can specify this additional parameters to Sshoogr, saying that this is the intermediate directory we're copying the files to, and this is the command we have to execute after the file is being copied. So in this way, the Sshoogr DSL, the file copying DSL stays in the same way as you saw it here. Just in this case, you can also use sudo functionality to actually copy the files in the locations that where original user can copy the files. Also, exec method is not as simple as just one string. It actually has an ability to you have an ability to override many options of that. So it actually takes a map as an input where you can specify different parameters. First of all, of course, the main one is command, which is going to be executed. But also you can specify that you don't want to fail an error if you don't want to show output, and a couple of others. And also you get a result back, which makes it very easy to write any logic inside your Groovy script to do some kind of processing on kind of local machine, not remote machine. And I think, again, if you guys, some of you have been on clean code talk before that, I think this is one of the main powers that Groovy gives. It allows you to express yourself much better. So things like that is actually like sorting, going through the output and finding the line with warning. Things like this, they can be implemented in Bash and in shell script. With the help of set commands, awk commands. But every time I meet a statement or like a command with set, awk, grep combined, I always have to think, what is this doing? In Groovy, you can actually delegate part of this filtering logic. Instead of implementing that in shell script, you can implement it in Groovy and give it a much better explanation because you use more easier to understand abstractions. Here we just iterate over lines and we do some comparison. Well, we can of course pack it into one command in Bash, but it doesn't read that well than few more lines in Groovy, in my opinion. So yeah, this exec method, it gives you a full object which contains the exec code and the output of the remote command, where you can add a lot of logic on top of that. And also there are some shortcuts to simplify it even more. So there's OK method, which takes just takes a command, and as you may guess, if the command fails, if the command returns non-zero status, then this will return false, and if it's 0, then it's going to return true. So it's very easy, again, to build more complex logic on top of remote command execution. And the same with fail. It's just the other way around. Sorry. So tunneling, the next thing that Sshoogr provides. And tunnel basically takes two parameters to which server we want to connect to and which is the port that server is running. And the way the tunneling works is that actually SSH client, which in our case is Sshoogr, is starting a server on local machine where you're running the script from, and it starts that on a random local port so that you don't clash with, actually on random open local port, so you don't clash with any other servers that's running on your machine from which you're running the Sshoogr script from. And you can use that port to actually do stuff over the firewall or over the jump server to which you connect to. And in this case, again, we just have all the libraries we can use in Groovy. We can use that, of course, in Sshoogr. And you can, in this case, just take the URL text from a remote machine running over tunnel and do some logic around that. Very handy. Also, Sshoogr provides few things to simplify command execution, like prefix and suffix. So basically, when you have this prefix method, then everything that happens inside that, and any exec that happens inside the prefix will basically get the prefix. And basically, each command will be executed with sudo. And the same with suffix. I hope it's quite obvious what it does. Oh, sorry. So more features that Sshoogr has. It has ANSI color support. So if your terminal from which you're working on supports ANSI coloring, then Sshoogr will give you a bit of help there, trying to highlight the most important things. Also, if the remote command that you're executing also does some ANSI coloring, then it will be also shown here. So quite handy for navigating large outputs of big commands. And let me show you how it works. So this is a simple script. I hope you kind of get from the name that it just shows you some rainbows. And let me show that it works. I have this script. So this is the full script. Do you see it well? This is the full script that connects to my local Vagrant machine, the VirtualBox machine. But it's using private network, so it's actually connecting it to it on a real IP address. Well, real, that is only visible on my machine. But if I do run Groovy, Rainbow Groovy, well, you see the result from my yesterday's run, pretty much. But I'll show you. Oh, yeah. So the ANSI coloring is supported, and in here we just executed one command in Bash, and we got some nice output out of that. Also, it supports download progress. So if you download a big file, it will show you. It will not let you wait there. It actually will show you the progress. I can actually show that as well. Groovy download or Groovy. Let's see how it works. Have you seen it? Let's do it again. Boom. It works. And the downloader Groovy is very simple as well. So it looks like this. OK. Another thing that you probably wouldn't expect from any SSH library is that actually it supports HTTP proxy. And I actually did know that as well for a while, that you can actually run SSH connectivity over HTTP. So you can just specify the proxy host, and it will try to connect to the remote machine over the proxy host. I don't know, the only reason you can use HTTP, you may use HTTP proxy for is actually to have some auditing on top of your SSH commands. Other than that, I don't see why it could be important. But if you need that, you can do that. Another thing that Sshoogr has, it's not only a Groovy library, it is also an executable. So you can actually run things like that. So you can provide all the connectivity details inside the execution command, and you can specify the script that you want to run. And as you see here, it actually has the extension Sshoogr, which means that it's kind of a special script, even though it's still Groovy script, but with some additional goodies on top of that. Sshoogr scripts, for Sshoogr script, you don't need to install Groovy, so you can just install Sshoogr and run the Sshoogr script directly, because Groovy is packaged with the Sshoogr installation. You can also omit all the grep annotations if you have a standalone Groovy script, so you don't need to write them anymore. You just use the Sshoogr syntax. You can omit connection details because now you can delegate them to the executable command to extract them and run them from there. And this makes the scripts themselves more portable because you don't need to put all the secrets, all the connectivity details into the script. Plus, it gives you a bit of like Ansible-like experience, but with the help of Groovy, basically. So yeah, and it's the same syntax. It's the same Groovy. You can still use other libraries, but just you can start writing Sshoogr scripts just with the remote session and exec commands. And the best way to get Sshoogr executable on your machine is using SDK-man. How many of you guys actually use SDK-man already? Oh, most of you, nice. So yeah, I think SDK-man is the best addition to Groovy ecosystem since Groovy itself. Because yeah, it's the easiest way to install things and the easiest way to manage multiple installations of different SDKs, including Groovy itself. And the same goes with Sshoogr. So you can just install Sshoogr with specific version, and then you can use that. Okay, I wanted to show you how it all works, but hopefully you guys still already know that. So I already installed Sshoogr executable before because the internet is not quite stable. But let's see what I have here. Oh, the wrong name. It's going to the internet, I guess. Zero, 1. And I can run the Sshoogr script now. So as you can see, I didn't even provide the path to the file because actually this directory has default.Sshoogr file, which is being executed when I run Sshoogr command. So it's this is the file basically, a few lines of code. Okay. Some other stuff. The thing is that, well, how many of you guys do use Intellij IDEA? Oh, everybody. Nice. The thing is that, and I don't know if you guys know that, but Intellij IDEA has support for Groovy DSLs, meaning that if you have a DSL and you want Intellij to understand that DSL a bit better, you can actually extend Intellij with a simple GDSL file to make some hints for Intellij to actually help you out with code completion and the actual types of things that are used. And that's what I can do with Sshoogr scripts as well. So you have to add a new type, new file type called Sshoogr, and make it like a Groovy file type. And this will actually, and if the Sshoogr jar is on your class path, then it will know automatically how to support that. Let me show you a bit of demo here. So not this one, not this one, this one. So this is the file that I was editing before. Let me put it to, do you see it? Should I use the light? Okay, so this is a Sshoogr script inside Intellij, and I can, if I type in something, it will actually help me out. It knows all the methods from the DSL already, and also if I go for like a SCP, I can, do it very quickly. Local file. It will show me all the methods, all the types that it has. So it's very handy support by IntelliJ for Groovy DSLs. And if you have your own DSL, you can actually extend. You can extend IntelliJ to support that as well. And the way it works, I'll show you, is by simple GDSL file that you can put to the jar of your DSL. And as soon as it's on a class path and IntelliJ sees that, it kind of helps you out. So in this particular case, what happens is we basically import all the methods that we have in default SSH class, which is the entry point for our DSL. We add them to the scripts that end with Sshoogr. So all Sshoogr scripts will get that automatically. And basically, the remote session method is a special one, which also has some magic going on here. It's not that hard to write, and it's not that hard to grasp. It just, it takes a bit of time to understand it, but it's worth it because then you can use your own scripts with your own DSLs inside IntelliJ very easily. And if you want to know more about IntelliJ Groovy DSL support, you can go to that link. It has much more information about that. Okay, another thing that we had to develop while we were testing different things with Sshoogr, because testing SSH against anything, if you need to test your SSH wrapper, you have to run it against real SSH server in order to have some sort of good feedback from the tests. But usually it's not that fast, and plus you need the server itself to be running somewhere. And it's not always running, and yeah, it's maybe a problem. So we created a mock, SSHD mock, which actually is capable of serving commands and serving files. And the way it works is that you have just a single class where you define your expectations for the commands that you want that your SSH client will send to you, and you can override pretty much any aspect of the command execution. So if you have a command, let's say, if you have some command pattern like ls something, then you can override the standard output, the standard input, the standard output, the error, the standard error, and then you can also override the environment. Plus, you can return some exit code when the command succeeds. And in this case, we're basically simulating the output of the ls command and returning 0 status. And you can go further with that. You can define more patterns. You can define. You can override things. And you can also define file expectations like this. So if the file exists. So if you try to copy some file, it will actually try to make it look like it actually exists. And the last thing you do with the mock, you basically start it as a server. Let me show you how it works. So again, we have a simple Groovy script, which can start you a mock file, a mock SSHD server, and this is what pretty much I showed you before. We have defined expectation for a ls command, and the way I call it from, and let me just start it. I start the mock. Mock is started. And now I will try to execute a command against that. And then the way I do it, I use simple SSH client, SSH executable from command line. And I'm specifying the port because it's a different server, a different port it's running on. And I specify the command I want to run on that. And obviously it's connecting to the local host because that's where I run it. And I can specify any user because mock doesn't care about security that much. So if I run it, I'm actually connecting to my machine, my mock server, and it actually returned the expectations that I put into the mock server. So if you have some scripts that you want to test or you want to actually act in the way that in an expected way, then you can use SSHD mock to actually make it happen in test environments or some other environments if it's needed. Okay. Another thing that we had to do at some point is that we actually started developing some isolated infrastructure as code functionality, like Puppet modules, Ansible roles, something that we had to deliver to our clients as a separate package. And we needed to test those packages in one way or another because we had developers. We wanted to reuse the practices we use for application development, also to reuse them for infrastructure as code. And the way we did it, basically with the help of some virtualization and Sshoogr, we created a small library called punit. Okay. punit, which is a provisioning unit, which basically is a combination of Sshoogr and JUnit, which allows us to execute integration tests against remote machines with the help of Sshoogr syntax and get a JUnit report which we can publish into our Jenkins or any other CI server, which was pretty handy for us. So the way you define punit is pretty much like this. So you have a base class, which is called Puppet unit because it was the first integration tool we used it for. And then inside your test, you can verify the state of your provisioning. So after the Puppet or Ansible or Chef has finished the provisioning cycle, you can verify the state of the server and report it back. And then, because there was a virtual machine, basically, we're stopping and starting it on before the test, provisioning that, and then stopping it in the end after the test. And this way we could actually test on different various operating systems and various configurations of the same module. So yeah, it happens in very simply. So we have all the access to the full Sshoogr syntax, plus we have some additional goodies like file tags, and we can check to write normal asserts as we do in JUnit, or you can actually use Spock for that as well. Why not? And then you can combine a test that verifies the state of your provisioning infrastructure code. Plus, if you need some tunneling, for example, it's also possible. I mean, it's working the same way. If let's say, the infrastructure from which you are testing on is actually located behind the firewall, you still can do that by implementing some kind of tunneling on top of that. And this particular code was testing the SVN installation module for Puppet. And I actually was using Java libraries to test the SVN connectivity on the provisioned server in Amazon. And all that happened with the help of Java libraries plus Sshoogr syntax on top of that. And of course, whenever you can automate something, then you should put it together into CI integration, and you get nice reports from running JUnit or in any other testing framework. And you can also report on that to your management. Another interesting thing that I found out not so long ago, and maybe it doesn't have so much press, but it actually is quite awesome what you can do with that. It's called TAP, Test Anything Protocol. And pretty much the Test Anything protocol is described in these 5 lines, so nothing more. Well, there are some other things, smaller things, but to understand the TAP protocol, you just need to understand what's happening here. It's just we have the number of tests, plus each one of them has run, and we have 2 tests that fail, 2 tests that succeed. That's all. That's the Test Anything protocol. And the TAP protocol has implementations in Perl and Java and Groovy. In Ruby and some other languages, because it's very simple. And I guess you can write your own implementation of parsing or producing stuff in a few seconds or a few minutes, because it's very simple. And of course, you can also do that with Sshoogr. So if you want to verify a state of remote machine in one way or another, and you have a set of commands you want to run against that machine, then you can define your test like that. So it's a simple map, as you can probably guess. We have a map of the test of the name of the test plus the command we want to execute for that test. So in this particular case, we're testing that SDK man is installed, and we're testing that it has 7 groovies on our remote machine to make it very groovy. And what you can do with Sshoogr is just iterate that map, and for each of these commands, you just execute OK, and if it's not OK, then you produce different TAP output. And what you get as an output is normal TAP output, which can be parsed. Let me show you. I have a simple tab script written in this way. So all the things I showed you in a few slides, this is the script that does that. So as you see, we have these tests, and we have this looping, and we just testing that we are the commands are okay or not okay. And I'll just execute this. So we get the output, as you see. So we have the first command was okay, and the second command was not okay, because I actually only have 6 groovies installed, not 7. And the good thing is that, for example, in Jenkins, there's a tab plugin, which basically is capable of parsing tab output and putting it on as a report, in the same way as it would do for unit tests or any other testing framework. So you can combine the testing of your infrastructure into Jenkins very easily with the help of tab. And also, Sshoogr has a Gradle plugin, which allows you to run Sshoogr scripts directly from Gradle. Actually, it builds in the Sshoogr DSL directly into Gradle. The way it works is the same as for many other plugins. You have to provide the ID and then say that you want to apply the secure shell plugin. And then inside your task, inside the Gradle code, you have access to the full Sshoogr DSL that you can use for any of your tasks. So in this case, it just looks like that. So we have a remote task, remote session. And of course, you can also one of the ways I usually use Gradle and Sshoogr together is that I extract the connectivity functionality for my machines into Gradle properties. So I define project properties inside Gradle properties, and I reference them in the Sshoogr configuration. But I do not commit them, of course, because I don't want other people to see my credentials. But I let other people to define them themselves. So the file, the Gradle properties file that is inside version control pretty much looks like this. So we know that this will fail if you don't set your user home's properties. But if you do, it will work for you. But to give you a warning, it will actually complain with the default one. So let me show you a little demo again. So this is the full Gradle script that does that. So we have some connectivity options here. We're connecting to our remote shell, and as you see, I have extracted the connectivity user and password into Gradle properties. And this is the same script we executed for Rainbow, but just put it into Gradle. And I can, just do Gradle remote Rainbow. Yeah, that's it. That's the Rainbow. Okay. We have a few minutes left. So Sshoogr has a little brother, which is called Groovin, which basically is similar DSL, but for WinRM functionality, WinRM connectivity. So the thing is, for our clients, we had a lot of Windows machines which do not have SSH on them. So we had to invent something that works for them. And WinRM is more or less default thing in Windows at the moment, but I've heard that Microsoft actually is switching to SSH as well, so they're going to provide in Windows 10, I think they're going to provide SSH connectivity as well. But before that, WinRM is probably the default one, and it's the WinRM, the Groovin DSL is very similar to Sshoogr. It's just that it works with the WinRM protocol. And initially, we had an idea to actually merge them together, but the thing is that that Windows code, Windows provisioning code, will never be the same as Linux provisioning code. So there's no reason to build abstractions around them because it's going to be always different. So we decided to leave them as 2 separate projects. Okay, a bit of summary. So Sshoogr is battle-tested Groovy DSL for SSH connectivity. It's executable and portable scripting tool. It's easy integratable with any Java and Groovy library. Sshoogr can be used for many things, and like any SSH tool can be used for anything, like for provisioning your servers, IoT devices, executing remote orchestration commands, gluing all together, testing, monitoring stuff, all that can be done with Sshoogr. There's a bit of roadmap that we're going to introduce some new features in Sshoogr. And of course, if you guys want to contribute, we'd be happy to board you in. It's all on GitHub, it's all open source. And I guess that's it. Thank you. And if you have any questions, just shoot.
Are there any plans on integrating with the Jenkins pipeline DSL? Jenkins pipelines use Groovy. Are there any plans on integrating there? Because I think there's some limits on the language use of inside the pipeline. So I don't know if it works out of the box.
Well, I mean, you can actually integrate Sshoogr with Gradle, and Gradle is part of, it can be part of any, as a build step in any job. So, yeah, we didn't have any specific plans on that.
Yeah,
but
regarding this question is that if you want to use it in Jenkins pipeline, for now in Jenkins pipeline you cannot add a custom class path. So you can use it Gradle, or you execute as a shell script the Groovy class. This is another option that you're doing now in the shell. And the other thing is about the integration for the graphs, because you need to integrate the graphs in the Jenkins pipeline. You need to do something in your plugin. Maybe also it's a question is if these graphs also works with Jenkins pipeline.
Well, not at the moment.
No. Okay. Yeah. If you want to do it, it's like extending one class. And that's all. Yeah.
Okay. We'll take a note. Any other questions? No? Well, thank you then.